Okay, good morning everyone. This is Puya. Just gonna continue working on DC-DC converters. Before the second midterm, we started seeing boost converter, which is also called step-up converter. Now we're gonna see another family of DC-DC converters, which is called buck converter or step down converters, which, as it's evident from the name, basically this kind of converter converts a voltage to a lower voltage. But before we start seeing the topology of the buck converter, let's just do a review of why we use buck converter. So first of all, you have seen in your physics courses and like in your other courses something called transformer, right? Which is basically something like this. It has a core, has two windings, primary, secondary. Let's say this one has N1 rounds, this one has N2 rounds. So if we apply voltage here, then we have an induced voltage on the secondary side. So we just want to see why we cannot use transformer for DC voltage. So this is basically a coil, right? This is like similar to an inductor. And as you know, this is the characteristic of an inductor. This is like how the voltage and current of an inductor are related to each other. So assuming that the resistance of the coil is very small compared to its inductance, this is what we have here. So if we apply a DC voltage on the primary side of a transformer, so this is the voltage across the inductor, it's going to be, or across the coil, it's going to be a constant value. So it means that the rate of change of current, it's going to be constant. So it means that the current, it's going to increase because the current, it's going to be 1 over L of integral of V dt, right? So if this is constant, it means that current, it's going to increase with time with a slope of, let me just like put that V1 t. The current, it's going to increase linearly with the slope of V1 over L. And you also have seen the concept of flux related to an inductor. So in a very short period of time, we would have a high current that goes through this primary coil, and it would generate a very high flux, and that would saturate the core of this transformer. And basically we get to a point that current increases, let's say from 0, and then in a very short period of time. So if I want to be realistic, it's just like in a very short period of time, the current increases linearly based on the inductance that we have, and then it gets saturated, right? And further than this point, then there's no change in the flux. So when there's no change in the flux, the voltage across the second coil, which is an induced voltage, it's generated by the change of the flux, right? If flux is constant, then there's no voltage generated or induced on the secondary coil of the transformer. The other problem with this setup is that because of this high current, it basically means that we're gonna have a huge amount of current going through the coil, and this might basically like melt the wires or the cables, and it might damage the transformer, because the transformer is not designed to work in the saturation mode. It's designed to work in the linear mode, right? So like if it works all the time in the saturation mode, then it might basically damage the whole inductor. So not only we can generate a voltage across the secondary coil, but also we might damage the system, basically the transformer and like all the wires and cables. So that's why we can't use a transformer to convert a DC voltage to another DC voltage, no matter if it's a step up or a step down kind of converter. So that's something I wanted you to remember. It basically, like if you apply a DC voltage to a transformer, it saturates the transformer, and in a very short period of time we have a high current going through the primary coil. We would have some flux, but that flux eventually it's gonna become a constant flux, which is equal to the saturation flux, and it's not going to change further than that point. And because of that, we don't have any voltage induced on the secondary side of the transformer. So that was one thing I should have mentioned. Then the second point I wanted you to remember, and I want to remind you about this. We discussed this before, especially now that we want to talk about the buck or a step down converter. So you guys have seen the concept of voltage divider. So if we have something like this, if we apply a voltage on this circuit, and we have two resistors, or it can be something like this, a variable resistor here. So if we just like do it like this, then we can basically step down this voltage using a voltage divider. And you guys know that this voltage V2, it's gonna be R2 divided by R1 plus R2 V1. And so we can step down a voltage using a voltage divider. What